All right, time for FRQB number 1, Unit 8. This one looks like a good one. All right. You know what my favorite part about this one is? It says no calculator, which is awesome because that means that we won't have to mess around with the calculator too much and we won't be blurry with our camera. Oh, I hope the shadow isn't too much. I tried to put the light somewhere else. Okay. Ooh, there's kind of a shadow. All right, let's do this instead. If it's shiny, it's shiny. Okay. All right. So here's the cool thing about this question. It says, let R be the region in the first quadrant bounded by y equals 1 over x, the x-axis, and the vertical lines x equals 1 and x equals k, and k has to be bigger than 1. Find the area of the region in terms of k. Awesome. Since this is 1 over x, I'm just going to integrate 1 over x. Is that shiny right there? 1 along the x-axis. And we know the integral of 1 over x is the natural log of the absolute value of x from 1 to k. But since I'm positive, I'm not going to need the absolute values. Ln of k minus the ln of 1. But the cool thing about this, ln of 1, excuse me, ln of 1 is just 0. So we're just going to go, whoop, that's 0. So this is just the natural log of k. Goodbye, music. Okay. All right, so that's cool. That's problem A. That's really, really simple. I like that. Now, part B says, write but don't evaluate an expression in terms of k involving one or more integrals that gives the perimeter of region R. Now, this is cool. All right. Now, this chunk right here is just going to be from 1 to k, so that's k minus 1. Kind of excited about this. So the bottom is k minus 1. This side right here is 1 into the function 1 over x, and because that's the point 1, 1, that length is 1, so that's the height of this side. This guy right over here, if you put k into the function 1 over x, you'd get k 1 over k, so that distance is 1 over k. But then here comes the fun part, because to find the length of this curve, you need the length integral. Collect from a to b square root of 1 plus f prime squared. So, oh, Mrs. Mac misses you all too. Little cameo. Oh, that was cool. Oh, she's the best. All right, so since my function is 1 over x, f prime is negative 1 over x squared, of course, and f prime squared is positive 1 over x to the 4th. Now that is what I will put into the integral. This is interesting because I don't know, right? Oh, don't evaluate. Good. Okay. So I'm going to go from 1 to k of the square root of 1 plus the derivative squared. All right. I think that's good. So if I put all those things together, the k minus 1 plus 1, the 1's will cancel out. So I've got k plus the 1 over k, plus the integral from 1 to k, okay, of 1 plus 1 over x to the 4th, with respect to kx, sorry. Okay, there we go, A. Part B, part C, we're already there. Region R is rotated about the x-axis to form a solid. As k increases without bound, find the volume of the solid or show that the volume is infinite. Oh my goodness, this is going to be cool. All right, so let's check this out. So if I take this bad boy and I spin it around the x-axis right down here, and I'm going to go whoop, whoop, and it's going to be spun around, zoom, 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 all the way to infinity. 1 to infinity. Now we know volume around the x-axis, we're going to go from 1 to k, but we're going to be sending k to infinity. I'm going to square, I was waiting for somebody to say and beyond. I'm going to square that, pi r squared. No, wait a minute. Yep, that's it. That's good. Okay, so 1 over x, the quantity squared along the x-axis. So that's pi integral 1 to k of 1 over x squared. Now we know 1 over x squared from 1 to k. We know that's a convergent integral. We know, just thinking out loud, 1 to infinity of 1 over x squared converges to 1. So I think that'll be kind of cool. We could use that knowledge and then just go pi times 1, which is pi. But let's show them we know what we're doing. So the integral of 1 over x squared. Oh, you could write that. You could write that. I know this is a p-series integral. Sorry, don't say p-series integral. I know this is an integral, and I know the rule. The 1 to infinity of 1 over x squared goes to 2 minus 1, which is 1. We better show them. Okay, the integral of 1 over x squared is negative 1 over x from 1 to k as k goes to infinity. And this is negative 1 over k minus negative 1 over 1. But because I'm sending k to infinity, this guy's going to 0. And I'm left with negative, negative, positive, positive, negative, negative, minus, minus, 1, 1. But because I had the pi there, I need to multiply that by the pi. And oh my goodness, we have a volume, a finite volume of this really, really, really cool shape that goes to pi. You say, could we find the surface area too? Not an AP topic. So that's really cool. How about that? We got a nice little question there. There's a little bit, it's a light, easier to see. Our area, our perimeter, and our volume if we go all the way from 1 to infinity. All right. Thanks, everybody. Thanks, everybody.
Bye.
Goodbye.